In this video clip, we want to address why do we need to find the sum of such a special series. There is a reason for this in our daily life, and it is very practical. So let's see how it was studied. Here, this sequence is actually called geometric sequence. It comes from very practical reason. If one person deposits $100 in a bank, then in 10 years, what is the total money if the annual interest rate is 2%? That's very practical because, everyone works with the bank at least once per month, almost sometimes every day. So if one person deposits $100 and the annual interest rate is 2%, then everyone knows is the initial amount plus the interest. At the end of the year, you should get $2 interest because the annual interest rate is per $100, you have a $2 interest. So it's 100 times 2%. 2% is 0.02. So 100 times 2, this will give you 2. But here we need to develop an algorithm to find out what's the value in 10 years. 100 times 1 is 100. So we pull 100 out, then inside we have a 1 left here, and here we have a 0.02 left. So 1 plus 0.02 is 1.2. So at the end of the first year, we shall have a 100 times 1.02. We know the money we get again one more time is 100 times 1.02, which is $102. That's the end of the first year. It is also the beginning of the second year. So at the beginning of the second year, the initial amount will be $102, which is this one, rather than $100, the beginning of the second year. Then the interest rate is not changed. It's still 2%. So then at the end of the second year, how much money would that be? Is the starting amount at the beginning of the second year plus the initial amount times the same interest. Again, the initial amount is the initial amount times 1. So we can pull the initial amount out. Again, here the interest rate is 0.02, but the initial amount is different. It's no longer 100. That's the beginning of the second year is $102. One more time. Now we pull this common $102 out. That's basically this one. That's basically this one. The one I'm marking, this one. And then we have 1 plus 0.02. And that's 1.02. So at the end of the second year, this will be the amount. Marketing. The end of the second year, this is the amount. then there is no problem that at the end of the third year is going to be here 100 times 1.02 cubed. The end of the second year is this much. Here the exponent is 2, right here. Here the exponent is 2. The end of the third year, the exponent is 3. Then the end of the 10th year, it says here the end of the 10th year, here the exponent is 10. Okay? Remember, the end of the 10th year is the beginning of the 11th year. Okay? So that's how we got this picture. You see the first 100, the end of the 10th year is that's how the 11 comes from. Okay? So you may want to write in this way. Write in this way. 100 times 1.02 to the 10th. Okay? And here is A11. That's the beginning of the 11th year. Okay? It's no longer 10. Here the sub-index is 11. The exponent is 10. Now that's for the first 100. The second 100 is that this person may determine or decide that at the beginning of the second year, this person may want to deposit another 100. So every year, at the beginning of every year, this person may deposit $100. Okay? Then the second 100 will no longer receive 10 years interest. This second deposit only receives 9-year deposit. That's why here the exponent is 9. Again, the end of the 9th year, that's the beginning of the 10th year. Okay? So that's how for the second deposit, 100, starting at the beginning of the second year, you have this much. You have this much. Similarly, at the beginning of the third year, you deposit another $100, then the amount of money will be this. The third deposit will only receive 8 years interest. That's why here is 8. All right? And then here is the beginning of the 9th year. So that here is A9. So similarly for the 10th deposit, then at the end of the 10th year, the money will be this much, $102, because the 10th deposit only receives 1 year interest. That's why here exponent is 1. Okay? Now, for the last deposit, 11th year, the beginning of the 11th year, you deposit 100, but this is the time, last time you deposit the money, you get no interest. Okay? So this is how we get 11 tenths, A1, A2, A3. And here, exponent again, here, it's always 1 less than the index. The index stands for the 10. The first 10, the second 10, the third 10, we count backwards. Actually, this should be the first 10, right? But you know, to make the things simpler, here we say the last one is the first 10. We count backwards. All right. This kind of sequence is called geometric sequence. Here is because The following term we say A4. Use example A4 over A3. A4 over A3 is 100 times 1.02 cubed divided by 100 times 1.02 squared. The ratio here is 1.02, which is denoted by R, and which is called common ratio. Okay, common ratio. So for geometric sequence, there is a common ratio. And we can see here is the general formula right here. Comes from what? Comes from all down right here. You have A1 is 100, so here A1 stands for 100. And R stands for 1.02 right here. Okay? So 1n here is 1, 1 minus 1 is 0 on exponent. Remember, R to the 0 is 1. R to the 0 is not 0. R times 0 is 0. R to the 0 is 1. Okay? So 1n is 1. You have A1 equals A1, and R to the 0 is 1. Okay? So this formula is correct for A1. Of course, it's correct for A2. A2 equals this one. Well, A is 2 here. Here is still A1, which is 100. And times R to the 2 minus 1 is 1. That's exactly the exponent. This formula is correct. You want to generalize this formula. That's what we are doing in the college. It looks complicated. It is actually not. The mathematician wants to make things easier. So we then find out we do have a need. We do have a need to find the sum. Here is only for 10 years. People may do this for 20 years. Then you have a 21 tens. They may do this for 30 years. You have a what? 31 tens. Then that's going to be a big job for you to find all those, the sum of all those tens. We need to find a simple formula to do that. You will see this in the next video clip. Okay? So that's the reason, rationale. To understand this general formula, don't be scared. 11 tenths. S stands for sum. That's 11 tenths. From 1 to 11. So that's why here I runs from 1 to 11. Okay, AI stands for A1, A2, A3. So I runs from 1 to 11. Very clear. And this AI, and this is A1 times R to the I minus 1. Again, exponent is always 1 less than the index here, sub-index of A1. That's exactly I wrote right here. A1 is not changed. It's always what? 100 right here. Okay, that's why I wrote 100. Okay, and 1.02 is actually all R. You see right here? Okay, and then here is always exponent is 1 less than what? 1 less than the index right here. Okay, so that's the general formula. Please understand that. It's going to help you later on if you want to learn more math. Okay, so that's the reason. Again, it's not it is indeed there is a need in our daily life. It's not because mathematicians want to make things complicated. It's mathematicians want to find an easy formula to add those 11 terms, sometimes 21 terms, 31 terms, 41 terms with an easy formula. To see how we are going to find out that easy formula, you will see next video clip right here. And that's the easy formula. is 1 is just 11, just calculated in this way. Very easy. So to see how this formula comes from, click here or use your phone to scan this QR code. It's going to explain to you this process. Okay? So I will see you in the next video clip.